Moving on to chapter 7. It's cold in here today. Again, I wish this temperature would go up and make things feel a little bit better in here. But it is what it is. I just put a hat on and 3 layers of clothing and whatever. At least I don't have my winter coat on yet. Will probably later today, but not yet. Still early in the morning here. So we're going to start chapter 7 now. We're only going to do a couple sections out of chapter 7. We're actually going to I'm tapping my finger over here. We're only going to put a couple sections. We're going to put it together with chapter 8 here a little bit. So we're only looking at about a week for a couple chapters here. We're going to start out with the trig ratios. Today, sine, cosine, tangent, ones you've heard before. But then we're going to add 3 others, cosecant, secant, and cotangent. And just going to learn the basics of right triangle trig today with those, along with finding missing sides, missing angles. I'm talking about the law. I'm talking about angle of elevation and angle of depression problems is what we're going to kind of look at today. And then we're going to go into kind of over the left of the chapter, we're going to talk about the law of sines and law of cosines, how you go about finding missing angles and sides of triangles that aren't right triangles necessarily. Bring in a couple new things with that. And then we're going to go into what we call the unit circle, which is a huge concept in pre-algebra. So we're going to do we're going to go with a brief introduction to that, just introduce that to you and how we go around the unit circle and all those different types of things within this unit. But we're going to start out today with trig ratios, and like I said, we've got 4 things really that we're going to do. We're going to work on writing the ratios. We're going to work on finding the length of missing sides, and we're going to work on finding missing angles. And then we're going to talk about angle of elevation and angle of depression, which is just going to allow us to find missing sides and that kind of thing. So first of all, the trig ratios. There are really 3 sides of a right triangle, obviously. When we're talking about that right triangle, we've got 2 legs. The 2 legs make up the right angle itself, and then we have the hypotenuse side of it. Again, things you should remember. Again, we've got a leg, and we've got a hypotenuse. The hypotenuse is always the longest side of a right triangle, so kind of always keep that in mind. If you look at the demonstration or the thing that we have over there, you'll notice that we use the Greek letter theta. That's really what we use quite often to represent acute angles in right triangles. Angle theta is the observation of, the angle with measure theta. And oftentimes we call that our reference angle. That's the angle that we're kind of looking at when we're doing all of these things. And when we're labeling right triangles, which we have to do when we're talking about trig ratios, that's the angle that we base different things off of. So a couple things within that diagram. It talks about the adjacent side and the opposite side. The adjacent side forms the given acute angle with the hypotenuse. I just kind of say the adjacent side and the opposite side can change around. The hypotenuse is always going to be the hypotenuse. The hypotenuse is always going to be the side opposite the 90-degree angle. That's the hypotenuse. The adjacent side and the opposite side, those change based on where your reference angle is. In this case, theta. In this case, we've got theta sitting here in the upper corner here. So the side furthest away from it, or opposite or across from our acute angle that we're looking at, that's the opposite side. It's the one kind of furthest away, or it's the side furthest away from our theta or our reference angle that we're looking at. The adjacent side is the side that I always just kind of say is in contact with our reference angle or our angle theta or our acute angle. That's not the hypotenuse. And obviously, that hypotenuse is exactly what it is. Okay, so the first thing you really have to be able to do is you do have to be able to label these according to the angle that you're given as opposite, adjacent, and hypotenuse. And again, this was already done kind of in this drawing. That comes then to the 3 trig ratios that you've talked about in geometry, and you've probably talked a little bit about in algebra: sine, cosine, and tangent. Those are our 3 basic ones. Sine is the length of the opposite side over the hypotenuse. So sine is opposite over hypotenuse. Cosine is the second one. Cosine is adjacent over hypotenuse. It's the length of the adjacent side over the length of hypotenuse. And it's just a ratio. And then tangent is opposite over adjacent. Okay. What do you do when you stub your toe? You soak a toa. Dad joke. Siri wasn't here to do it, so I thought I'd do it myself. So soak a toa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And they're just the ratios. And again, you've got to understand that the opposite and adjacent sides are based off of your reference angle. So the first thing we'll end up doing here in just a little bit, when we're looking at a couple of examples, is we'll start by labeling them first. Okay, so those are the ones that you're relatively familiar with. The three that you are not, these are the reciprocal trigonometric functions of angle theta. And they're really formed by just taking the reciprocals of your other ones. So there's the cosecant, CSC. The cosecant is the hypotenuse over the opposite. So it's kind of the reciprocal of the sine. Cosecant, reciprocal of sine. The secant of theta is the hypotenuse over the adjacent. So it's the reciprocal of the cosine. Secant is hypotenuse over adjacent. And cotangent, the one that makes sense, is the reciprocal of the tangent. So it's adjacent over opposite. And it's just lengths of those sides. And you're just going to write these different ratios for these different things. So we've got sine goes with cosecant. Cosecant goes with secant. And tangent goes with cotangent. Why doesn't S go with S and C go with C? I don't know. I'm not smart enough to know that. And somebody way, way smarter than me did all this stuff. I just have to teach it. So those are our 6 ratios. So the first thing we're going to do here then is we're going to be given a diagram, and you're going to ask to write the 6 trig ratios. So the first thing when I'm writing the trig ratios that I like to do is I like to identify the opposite, adjacent, and hypotenuse sides by just kind of writing the letters. So if I look at this triangle over here, I've got my theta right there. So the side furthest away from it, that's a leg, is my opposite. So 21 is going to be the opposite. That makes 20 the adjacent because that makes up the 2 legs. And then 29, which is the longest side, which is opposite the 90 degrees, is the hypotenuse. So now I've got them listed. So now I have to write the ratios. So the sine ratio of theta is the length of the opposite side over the hypotenuse. 21 over 29. Cosine theta is going to be the adjacent, SOHCAH, so adjacent over hypotenuse. Those ratios always need to be less than 1. Okay, sine and cosine ratios have to be less than 1 if you were to divide them out. If they're not, you've done something wrong. Tangent ratio, opposite over adjacent, so 21 over 20. If you could reduce the fractions, you should reduce the fractions and do those types of things as well. They tell you to write them as decimals, whatever. So those are our 3 normal ones. Now we're going to go to our abnormal ones, and this is the way I like to do it. The cosecant goes along with the sine, and I'm just going to do the reciprocal, so 29 over 21. The secant goes with the cosine. It's just the reciprocal, 29 over 20. And the cotangent goes along with the tangent. It's just the reciprocal, 20 over 21. Okay. And there are the 6 trigonometric ratios of that given angle. And that's all they're asking you to do. You don't have to find the measure of the angle. You don't have to do anything like that. All they're asking us to do in this example is to find that. Okay. So I've got a second question down there, labeled 12, 5, and 13. I'm going to press the pause. There they are. Okay, so there are our ratios. So that's how we go about writing the ratios, which obviously is handy and things we want to be able to do. But really what Well, I guess there's another set of things I guess we have to know. Sorry, let's go back. In 3, 2, 1, go. All right, so next thing that we want to be able to do then is we want to be able to write the ratios if we're only given two sides. So, in this first case, we're given the tangent of 15 over 8. Well, we want to write the other 5 ratios for this. We only know 2 of them. So I'm going to go ahead and I'm going to draw this. And I'm going to go ahead and put the theta down there right now. It could have gone, up here if I would have wanted to. I just didn't want to do it there, so I didn't. So I put it down there kind of instead. Let's get that stuff out of there. Okay, so now I'm going to go ahead and label my sides. I know tangent is opposite over adjacent. So my opposite side here is 15. My adjacent side down here is 8. Well, we know it's a right triangle, and if I want to write the sine and the cosine and the cosecant and the secant, I have to know that third side. So what tool do we have to use the third side of a right triangle? Well, we've got good old Pythagoras. So we've got a squared plus b squared equals c squared. A and b are the 2 legs. So that's 15 squared plus 8 squared has to equal c squared. 15 squared is 225. Plus 8 squared is 64, so this is 289 equals c squared. Square root of 289 is 17. So now I know the length of that hypotenuse is 17. Now, again, according to theta, this was our opposite, this was our adjacent, this was our hypotenuse. Again, you could go ahead then and do the sine, cosine, tangent ratios. You could go ahead and do that now, just like you did on the past one. I just wanted to kind of show you how you're going to find that third side. Okay, and again, there's another example down there. I'm not even going to do that one. Showed you how to find it, and you guys should be able to find that third side just using Pythagorean theorem. But again, just make sure you know that this one uses sine. So put your theta in one of your acute angles. It doesn't matter where you do it. This would be 24 this time, and this would be 25, and you have to find that one. Again, using the Pythagorean theorem, you should be able to go ahead and do that. Okay? So there's the first thing. Well, what's the use of all this? Well, what this stuff really and what all of these allow us to do is they allow us to find missing sides and missing angles of triangles, of right triangles specifically. So that's what we want to be able to do. Now understand these ratios, or sine and cosine, this given ratio creates a given angle. So if you have a ratio of sides that's 1/2, the measure of that angle is going to be, the sine measure of that angle is going to be the same no matter what you do. So we want to be able to find missing sides and missing angles of different types of triangles. So if we look at this example, it says a fire truck has an 84-foot ladder extending against a building, forming a 55-degree angle. The truck is 8 feet tall. The firefighters are trying to reach the window that is 75 feet above the ground. How will they be able to reach the window will they be able to reach the window using the ladder set at the angle that is given? Okay, so it's saying that it's 75 feet up is where that window is. We want to know if they put it at a 55-degree angle, is that going to be good enough? So essentially, they're telling us that this is 75. We don't know for sure what this height is, and we have to find that height right there. Now, in addition to that, with this question, they tell us that we're already 8 feet off the ground, so we're going to have to keep that little 8-foot thing here intact. But essentially, we have to use the trig ratios, knowing that this is 84. We want to find this value, knowing the measure of this angle is 55 degrees. Okay, so we're going to use one of really the 3. These are only going to use sine, cosine, and tangent. Those are the only ones we're going to use when we're finding missing sides or missing angles. So the first thing I like to do is, again, I'm given my reference angle is 55. I go ahead and label the sides that I know, and that's all I do. If I don't need to know it, I don't care about it. So x is the opposite side, 84 is the hypotenuse. So if I'm looking at SOHCAHTOA, SOHCAHTOA, O and H, so the sign uses opposite hypotenuse. So when we were doing these before, we always put sine theta. Well, we know what theta is in this case. We know it's 55 degrees. So we're going to put the sine of 55 degrees. That's going to equal the length of the opposite side, which is what we have to find, over the length of the hypotenuse, which is 84. Now understand, the sine of 55 is just a number, okay? It just creates, this angle is created by a certain ratio that they always have, that these sides always have. So we can figure this out. And the way we're going to figure it out, again, we're going to use our calculators. So we can cross multiply. So if we go 84 times the sine of 55, that has to equal our x values. So we're going to turn on our calculators. And the first thing we're going to do with our calculators is we're going to hit the DRG button. It's backwards, but that button right there. And you need to make sure that you're in DEG mode. You have to be in degree mode. If you're in rad or you're in gradients, you're going to get the answer wrong. So make sure you're in DEG mode. Now that we know we're in DEG mode, I'm going to hit 84, sine 55, close the parentheses, and that tells me that my x value here is 68.8. Okay. So this value here is 68.8 feet. Now the question says, is that good enough? We got to remember we're 8 feet off the ground already, so if we add 8 to that, we're at 76.8 feet, so we're above the window that we need to be. So setting it at that 55-degree angle in this case is good to go. Okay. Could we set it a little less? Yeah, probably, but that's not what they asked us to do. But also, again, keep in mind that 8 feet there. It's sitting there, so we've got to use it. That's just the value that it's off the ground. So always kind of keep that in mind when we're talking about these different types of problems. Okay, let's look at another one. So the sun shines. You are my sunshine, my only sunshine. You make me happy when skies are gray. Sorry. The sun shines at a 60-degree angle to the ground. How long is the shadow cast by a 20-foot tall flagpole? I have to draw them. So I know I'm going to create a right angle. Okay, so here's my flagpole. There's the flag. I know the flagpole is 20 feet tall. It says the sun shines at an angle to the ground. The sun shines at a 60-degree angle to the ground. So I'm going to go with this angle right there is 60 degrees. It's called an angle of elevation. We'll talk about it in a second. How long is the shadow cast? Well, we got to figure out where the shadow is. Well, that's got to be a shadow. Okay, so we have to figure out what that is. Okay, so we label the sides according to where I put the reference angle. Okay, and I put it there because that's where it goes. But yeah, got to be careful. So 20 is the opposite. There's my right angle. This is the adjacent. Which one uses opposite and adjacent? Well, tangent. So we go the tangent of 60 degrees is going to equal the length of the opposite, 20, over the adjacent, x. Okay. So now the number's on top. So again, we're going to cross multiply. So this would be x times the tangent of 60 equals 20. Cross multiply that times that and that times that. We have to solve for x. So we have to divide by the tangent of 60. So we get out the trusty desk calculator, hit 20, divided by tangent 60 equals 11.54. So the length of our shadow is 11.54 feet. Finding missing angles using different trig functions. Okay. or I'm sorry, finding sides using different trig ratios. And you're going to use a lot of these, but again, the key becomes make sure you label the sides. The other thing we want to be able to do then is we want to be able to find the measure of an angle. So essentially the reciprocal, really kind of done the same way, sort of. You're still going to label the sides first according to what reference angle they have. You're going to write the ratio, but now we're going to find the length of the side. We're going to find the measure of the angle, so we're actually going to have to do it what we call the inverse of it. Okay, so if we look at question number 3, here's my reference angle here. That's my reference angle. Length of the opposite, 5.4 is the opposite, it's the furthest away. 13 is the adjacent, SOHCH, so that's tangent. So tangent of theta, that's going to equal the length of the opposite, 5.4, divided by 13. Okay, so now since we're trying to find the measure of the angle, you need your calculator. Okay, because this tangent ratio of 5.4 over 13, whatever that would reduce down to, that's always going to create a certain measure of an angle, no matter how big or how small this thing is. If we made this 10.8 and 26, that's the same ratio. So it's going to create an angle. So the way we do that on the calculator is we have to do the inverse of the tangent. So anytime you're trying to find the measure of an angle, it's inverse. So you hit second on first. You hit second tangent. And you should see something on your calculator that says tan -1. And then you're just going to put 5.4 divided by 13 inside the calculator, and you get 22.6 degrees. Okay, so the measure of that angle is 22.6 degrees. Okay. And you're done. You move on to the next one. So that's the measure of that angle. Could you find the measure of this third angle now? Yeah, you have to add up to 180. So you could certainly do that if we wanted to. Okay. Let's look at number 4. Okay, so I'm labeling the sides. Again, I'm just going to label what I'm given. So here's my reference angle. This is the adjacent side. This is the hypotenuse, so that's cosine. Adjacent hypotenuse, yep, cosine. So cosine of theta is going to be 5 over 12. So we're trying to find the measure of the angle. So second cosine, 5 divided by 12, rounded to the nearest tenth, 65.4 degrees. And they're done. There's 2 more down there. Try them. Answers will be on the other side. There are your 2 solutions. And then that leads us now to our last objective. Getting a little bit long. Leads us to our last objective. We're talking about what we call the angle of elevation and the angle of depression. The angle of elevation and angle of depression really do help us find lots of different things. But you need to know where those angles of elevation and those angles of depression are, because they do get quite confusing when we're talking about them. So in the diagram there, definition says an angle of elevation is the angle formed by a horizontal line and a line of sight to the point above the diagram. So this is kind of parallel to the ground. Our angle of elevation is that angle right there. It's the angle from looking straight out and up to an object. It's the angle there that's created. And we could create, again, just by dropping down, we could create a right triangle in there. So level to the ground and up is your angle of elevation. And that one's usually not too hard to figure out where it is. The one that everybody messes up in is the angle of depression. The angle of depression is formed by the angle looking straight out and down to the object. So it's that distance down to the object that you're looking at. So like right there, it's kind of, you're talking about your plane, and you're flying in a plane going this way. You're going this way, and you're looking down to the airport, and you have to figure out what angle you're going to do. I mean, you want an angle of depression when you're going down and landing at an airport that's not too steep, otherwise you crash and die. So that's the angle of depression, and the angle of depression is missed a lot of times. It's put in the wrong spot. So remember, it's down. The other thing you have to keep in mind is that really you've got this line and you've got the ground. They're two parallel lines being cut by this hypotenuse. So they're alternate interior angles. And alternate interior angles are congruent. So really the angle of elevation and the angle of depression, they're congruent to each other. They're the same exact thing. So if you can't get it through into the noggin what that angle of depression is or be able to draw that, just understand it's the same as the angle of elevation. They have the same exact measure. Okay? So those are the angle of elevation and the angle of depression. Now, a lot of times with these types of questions are obviously story type problems. You have to draw them. You have to. And my suggestion to you is just there are two types of triangles that you have to draw. This nice straight triangle that I just created, if you see that its angle of elevation draw that triangle right away. If you see its angle of depression, draw this triangle right away. And then you can worry about where the angles go. Again, our angle of elevation is right there. Our angle of depression is right there. Now we just have to make things fit. So let's go ahead and do this one. It says a ship's sonar locates a treasure chest at a 12-degree angle of depression. Okay, so it's angle of depression. So that tells me that I'm going to use this triangle. A diver is lowered 40 meters to the ocean floor. So here's my boat. There's my boat. The diver's being lowered 40 feet. I know my angle of depression is 12 degrees. It wants to know how far to the nearest meter does the diver need to swim along the treasure chest along the ocean floor to get to the treasure chest. Okay. Again, this is kind of a little bit backwards of our drawing, but essentially we want to find this distance right here. Okay, the drawing is a little bit suspect, so to say, but it's going to look something like that. So we're going to use trig ratios. We've got the opposite and we've got the adjacent. So we're going to go the tangent of our angle equals the length of the opposite over the adjacent. Okay. Cross multiply. That's x times the tangent of 12 equals 40. So we're going to divide 40 by the tangent of 12. So he has to swim 8.5 meters to get to the treasure chest. Okay, and again, your drawing might look a little bit different, but make sure that angle of depression is where it's supposed to be. Sometimes figuring out what these drawings look like does become the hardest part of this. Let's look at another one. A sailor is looking at a kite. He is looking at a kite of an angle of elevation. There's my drawing. The angle is 36 degrees. Label my 36-degree angle of elevation. And the distance from the boat to the point where the kite is directly overhead is 40 feet. So my boat is sitting right here. My kite is up there. This is going to be 40 feet. It wants to know how high the kite is. That's the height of the kite. So again, we've got opposite over adjacent, so tangent. So tangent of 36 equals x over 40. Cross multiply, that gives us 40 times the tangent of 36. And it is flying at 29.1 feet. It's the height of the kite. Heights of the kites. lots of problems like heights of kites. Okay. Number 10, why don't you go ahead, press pause. If you want to press pause. If you don't want to press pause, don't press pause. The answer is just going to appear here in a couple seconds. Okay, so 7.2 feet is the answer for that one. And that's what that drawing is going to look like. I'm back. All right, last one that we're going to look at. It said 2 boats. So we got 2 boats observed by a parasailer 75 meters above the lake. The angles of depression are, okay, so we're looking at an angle of depression problem. So we're going to have a triangle that looks like this, but in actuality, this parasailer is seeing really, he's got 2 different triangles going on that he's looking at. So one of them is at an angle of depression of 12.5. Nice, I should learn how to write better. One angle is 12.5. The other angle that he has, and I'm just going to draw a second triangle here. The other that he has is 7 degrees. It says he's 75 meters above the lake. So this is 75 and this is 75. Okay, so essentially the boats are down here and down here. So I'm going to find this value and I'm going to find that value right there. But it wants to know how far they are apart. So since it's far apart, then I'm probably going to have to do a little bit of subtracting because this would be the distance there and the distance between them. So again, we're probably going to use tangent. Tangent, you'll find out, gets used a lot with these questions. So we've got tangent of 12.5 equals 75 over x. So cross product, we've done a few of them like this now. If you notice when the number's on top, you're going to divide by the tangent. So 75 divided by the tangent of 12.5. So that distance is 338. We'll just round to the nearest foot. Okay. For the second one, this is tangent of 7 is equal to 75 over x. So 75 divided by the tangent of 7 is 610 feet, 611 feet. It wants to know how far they are apart. So 611 minus 338, you get 273 miles apart. Okay. So those are the different things that you're going to have to do in this first day 1 of section 1. We've got our 6 trigonometric functions, sine, cosine, and tangent. We've got the 3 reciprocal functions, cosecant, secant, and cotangent. You're going to have to find the length of the missing sides by setting up the ratios. You're going to have to find the missing angles by setting up the ratios. Remember, when you're finding the angles, it's this inverse sign. So second sine, second cosine, second tangent to help you find that angle. And then the third thing you're going to have to do is you're going to have to do some applied problems with angle of elevation and angle of depression. Again, making sure that you're careful with that angle of elevation and angle of depression, especially the angle of depression one. Make sure you put it in the right spot. So that is it for today. We will see you next time.